So we're going to slow down just a minute and go over a few definitions. As we proceed through looking through UL assembly sheets, we're going to see these kind of words, so we need to make sure we're all on the same page. Let's first start with annular space. The annular space is basically the space between the penetrating item and the wall or assembly. In this case, it appears we've had probably a CMU wall, and they've cored a hole, let's call it 6 inches. And we've got maybe a 4-inch pipe inside here that's penetrating. So we're going to be fire stopping this area. In this particular case, I want you to look at the zero or point contact. This kind of language you're going to see quite often. In this case, we're going to have is we've got our pipe in contact with the edge of the opening. Some UL systems allow this, some don't. But when it does say 0 point contact, it will usually tell you to put a bead of caulk in this area. You also see sometimes the interior will have some kind of mineral wool or other kind of safing material placed within it. So these are definitions we need to be looking at and become very familiar with. So let's touch on a couple more definitions we're going to be seeing in a lot of our paperwork. The F rating is the time in hours that a fire stop system will prevent the passage of flames through an opening, remain in place, and not permit the projection of a water stream as determined by standard test method ASTM E814 or UL 1479. A T rating is the time in minutes required for the temperature on the unexposed surface of a fire stop system or any penetrating item to rise 325 degrees Fahrenheit above the ambient temperature as determined by ASTM E814 and UL 1479. As we saw in our first example, we're going to be talking about zero or point contact. A fire stop system that indicates a zero annular space as part of the range of acceptable annular space values is permitted to have a single point of contact between the penetrating item and the inside of the hole it is routed through. If the system specifically mentions that a continuous point of contact is allowed, then it is acceptable for the annular space to be zero all the way around the penetrating item. One term that's commonly used with fire stop sealant products is intumescent. An intumescent material is one that expands when exposed to heat. As a good example, let's talk about PVC piping. PVC piping penetrating a rated wall. We have a sleeve or some kind of collar that has an intumescent material. The PVC melts away during a fire event. When it melts away, the intumescent fire stop swells, closes the opening, and creates an effective barrier. It's a real world out there. Fire stop system details are hardly ever on the plans. Code officials generally do not ask for copies of approved fire stop systems. Tested listed systems rarely are installed correctly. Joints are generally not inspected during the framing inspection and installed to provide movement. EJs are being used when there are tested and listed systems available. Fire stopping is considered beneath some contractors. Most of the users are untrained. There's no licensed fire stop contractor requirement in most states. Above all else, remember this one statement. Through penetration shall be protected using systems installed as tested in the approved fire-resistant rated assembly. They must be installed exactly as tested. This becomes a very big issue in the inspection process. A fire stop pre-construction meeting is required by the ASTM standards. Fire stop of a through penetration is shown in these photographs. If you'll notice, the installer is installing mineral wool into the annular space around the iron pipe. They're then applying caulk and they're tooling that application. This looks like a good job. Unfortunately, it's not normal. Tooling of the fire stop product is critical to its application. Shown is proper application of a fire stop sealant or caulk. The annular space receives a certain amount of the caulk. There's also some tooling or sealant to the outside, allowing a bond to be created between the penetrating item and the substrate. Left untooled, the sealant will expand outward during a fire and will likely fail. So now I want you to look over some of these systems we have listed on this sheet. Kind of work out for yourself where they would apply and how they would apply. Take a little bit of time if you want to and go to one of the other websites such as STI or 3M or Hilti and do one of their workup plans and see what kind of listing they give you for their product in these numbers and these categories with these UL division sheets. Some key resources include 3M, Construction Specialties, Fireline 250, Hilti, STI, Thermofiber, and Rockwool. I encourage you again to explore some of these sites, look at the information that's provided, look at the training opportunities they offer also. It's always good to expand your knowledge in any way, in any avenue possible. Our first series of examples will be for through penetrations. For our first example, we're going to be using system WJ1153. This is for a rated wall with an F rating equal to the hourly rating of the wall assembly in which it is installed, be it 1, 2, 3, or 4 hour. For this example, we're going to assume we have an 8-inch CMU wall. We have a 2-inch steel pipe through penetration. In this case, when we look at our UL system sheet, we see that we are allowed to do this and our maximum opening would be 14 1/8 inch. So well within our range. For the purposes of this example, we're going to say that our opening is a cord opening. Let's say it's a 6-inch wall. We have a 2-inch pipe inside. The 2-inch pipe actually has 0-point contact. And in our UL system, we see that we are allowed to have a 0-inch to a maximum 1 3/8 inch pipe contact. So our opening may or may not be in compliance. We're going to have to measure this because if we are 0-point contact, this section could only be 1 3/8. Again, each individual UL sheet will give specific criteria for these installations. It's important to read the UL sheet completely and then determine the application as shown and in the field. Our next example is going to be WL1338. This is going to be a gypsum wall. It can be 1 to 4 hours. And again, as typically seen in a UL system sheet assembly page, you will see a note that says the hourly F rating of the Firestop system is equal to the hourly fire rating of the wall assembly in which it is installed. We're going to have a few examples on this one sheet. In this case, a 1 to 4 hour gypsum wall, wood or steel channels, 1 metallic pipe, conduit, or tubing. The angular space is allowed 0, which is point contact, to a maximum of 1 1/4 inches. At point contact, a minimum of a 1/2 inch bead of the Firestop tested system caulking product is installed. Also, this application must occur on both sides of the wall. We're going to use this for an example. Let's say we have a 1-inch steel pipe as our through penetration. Let's say the opening that's been created is 8 inches. Without doing a lot of math, it's pretty common that from the top of the 1-inch pipe to the top of that 8-inch opening is going to be much more than the 1 1/4 inch allowed. In this case, we would go back to the Firestop manufacturer and installer and ask them to provide another UL system sheet that shows compliance with the installed system, or to alter, change, amend the actual installation to comply with the UL system provided. These are the kind of examples you're going to run into in the field quite often, where either the opening is too large, the angular space cannot be correctly filled, the angular space is not protected. These measurements are critical. Again, everything in the UL system must match, and in this case must be on both sides of the wall. Sometimes we have situations where they can't get to only one side of a wall. They do make UL systems that apply for one side application. Again, everything must match. In our WL5217 example, the main item I want to point out is that we have insulated piping now passing through. This is listed as number 3 in the listing for the UL system sheet. This insulation can't just be any insulation somebody buys off the shelf. It's got to be very specific, and this insulation product data should be available so you can match to make sure that that insulation is in compliance with the UL system sheet. Multiple cables are identified in WL3348. While a sleeve is not required, in a gypsum board wall such as this, typically the sleeve is going to be used because there's no other way to protect the opening. Multiple cables are allowed, but a maximum fill of 27% in the opening is all that's permitted. Another thing to watch in this type system is the gypsum wall is for 1 and 2 hour only. So if you have a wall 3-4 hour rated wall assembly, another UL system would have to be designed. For cable tray penetration through a gypsum board wall, the framing of that entire opening must be completely framed in, and then the application can begin. The UL system sheet should be carefully reviewed. This is for cable tray installations. There are very specific limitations for these type applications. In this case, we have a maximum opening of 26 by 8 inches, 8/26. The actual cable tray is limited to 24 by 6. The cables must be less than 40% of the opening for the total value. A packing material, that's this right here, must be applied. This is typically a mineral wool. Again, the UL system will give very specific applications. And then on both sides of the opening, a sealant must be applied. There will be a specific criteria for the depth of that sealant, both as a wet or dry application. In this example, a minimum of 1/4 inch, and it's on both sides. What this also helps with is if we add cables at a later date or remove cables, it's a little bit easier to take out part of the sealant, part of the mineral oil, run new cables, and then reapply the application. Another penetrating item filler that's very good for this type of application is what we call pillows, and we'll discuss those more in a later slide. Our next example is WJ7067. This concerns ductwork through a rated wall. Ductwork has very specific criteria that we must look at, and everything again must match the UL system design. Steel duct, 16-inch diameter or smaller is all that's allowed in this UL system design. F rating, it's 1 or 2 hour. T rating is 0. Again, we're not going to be able to carry a T rating from one side to the other. The ductwork should be 22 gauge or heavier. In this example, we have a masonry wall. The sealant that is applied is required to be 5/8 inch in thickness within the annulus, that's this distance here, and then a 1/4 inch bead on each side. Also in our UL system design we have here retaining angles are required. One note is if you look in this ductwork we have point contact at the bottom. We have a bit of a space here. The 1 inch minimum lap to substrate requirement is seen in every UL system design. So this 1 inch of angle must overlap the opening. In this case, 1 inch angle may not work. We may be able to get the 1 inch here, but on the vertical we may have to use a 2 inch angle because we want 1 inch lap on the substrate. This is a common violation seen in the field. Following is an interesting example of a one-side application. In this case, we have a rated floor system with a through penetration. We have a toilet set above. We have to Firestop, restore the rating of this floor. Our UL systems provided with this particular system is going to be steel or cast iron piping. Because we can only access from underneath, we have to do what in the field they call a stuff caulk approach. We're going to put mineral wool, that's our number 4, in this area here. Then we're going to have caulk. Then we're going to have more mineral wool, number 4 again, and another layer of caulk. And then on top of that, there's going to probably be a bead of caulk. And again, the UL system will give you all this criteria. In construction, numerous types of joint systems occur in rated assemblies. These can be expansion joints, either vertical or horizontal. They can be slab of edge to wall type joint assemblies, head of wall joint assemblies, and slab edge curtain wall type assemblies. Safing at perimeter joints is a typical application in multi-story buildings. The concern here is that we have a fire event occurring on a lower level. We want to be able to prevent communication of smoke, gases, and flames from migrating from one level to the other. In this case, what we have is we have a slab that stops short of the exterior wall, a curtain wall, typically that's like a storefront type application. One of the first products we're going to deal with is mineral wool. This is 3A that we're identifying here. We're going to start off by using compressed mineral wool to fill this gap between the slab and the curtain wall. In our example, we're using a minimum 4-inch thick, 4-inch PCF density mineral wool bat insulation that is compressed in its packing to 50% of the joint width. This application must exactly be installed as the UL system design, or we can have failure of the entire system. So in our last slide, we saw that we had our mineral wool installed by the UL system design. So now how are we going to help hold all this mineral wool in place? The compression alone should help it, but we're going to apply either by brush or spray a fire stopping intumescent caulk that will overlap the substrate at the floor and the wall at least 1 inch. As we see, apply a minimum dry thickness 1/16 inch and overlap sealant. So this will be applied pretty thick, and when it dries, it should have a dried thickness of 1/16 of an inch. Again, follow UL system. Expansion joints created for building movement are typical for floor and wall assemblies. These systems and rated walls must also be protected. Again, UL system design sheets exist for all these systems. Typically, what we see in the field is, especially on walls, these systems are Firestop and then the wall is painted over, including the Firestop material. Many Firestop materials will allow you to paint over them. However, the inspection process becomes a little more tricky at that point. Again, during the inspection process, you'll have options. You can witness the actual installation for a certain percentage, or you can do some destructive testing. Either one is at the option of the inspector and the process for construction. Again, use the UL assembly, read it specifically, and make sure applications in the field match the UL system design sheets provided. Earlier in this program, we discussed some of the unique aspects of head-of-wall installations, specifically when they apply to rated walls and non-rated assemblies above. In this particular case, we have a situation with HWD 0370 where we do have a rated deck roof floor assembly above. We also have configurations A and B, one with a deflection track, one with not. Again, this is a design issue. The key components are that the application must comply with UL system sheets, and the application of fire caulk must occur at the top of the wall as shown in this drawing. One final note is quite often on some designs we actually have a fire caulk provision for the base of wall also. Within the building code, the general requirement is for membrane penetrations to comply with the through penetration provisions. There are 6 exceptions for those for electrical boxes. One is for boxes other than electrical, and one is for sprinkler penetrations. Obviously, membrane penetrations are different than through penetrations. Generally, code does not address how to deal with back-to-back penetrations. Membrane penetrations are to be covered the same as through penetrations, although we know that that just can't happen sometimes. Concerning dissimilar metals, the IBC provides some ambiguity as compared to NFPA 101. The IBC lists in 714.4.3 dissimilar materials. Non-combustible penetrating items shall not connect to combustible items beyond the point of fire stopping unless it can be demonstrated that the fire-resistant integrity of the wall is maintained. What we're talking about here is we'll have a situation where we have a metallic pipe that will pass through an opening, and then at some point it changes over to Concerning inspections and scheduling, the language in ASTM E2174 is a good point of reference. This gives very specific criteria for how the inspection schedule is to be laid out and what kind of notices are to be given. Again, referencing the ASTM E2174 concerning inspections, I particularly like 10.6. The inspector shall not supervise or in any manner direct any aspect of the installation process. This is just good advice for all inspectors. Inspectors should not be in the business of designing or offering fixes for issues. The ASTM E2174 offers two methods of conducting inspections. The first one is that the inspector shall be on site during installation and randomly witness a minimum of 10% of each type of Firestop being installed. The second method, per ASTM 2174 for inspections, indicates that the inspector shall conduct a post-installation inspection, which shall require destructive type verification of the Firestop and repair of the Firestop. A minimum of 2%, but not less than 1, of each type Firestop shall be inspected per floor or for each area of a floor when a floor is larger than 10,000 square feet. Any type of Firestop noted in the reports that does not comply with the inspection documents will require repair or replacement and reinspection of that Firestop plus one full additional inspection of the number specified. If non-compliance occurs on 10% or more of the quantity of like Firestops within an inspected area, that inspection shall cease. Inspector qualifications per ASTM E2174 are quite simple. The inspector must be acceptable to the authority having jurisdiction. Additional information for the AHJ is required in the appendix under the qualification sections. In that section, we see that they suggest that the inspector be one of the following: be a code official, an architect, an engineer, a representative of a quality assurance agency or an accredited testing laboratory, or a licensed professional in the construction industry. Additionally, in August of 2016, ASTM published E3038, Standard Practice for Assessing and Qualifying Candidates as Inspectors of Firestop Systems and Fire-Resistive Joint Systems. Now let's discuss installer qualifications. While almost all manufacturers of Firestop systems provide training for contractors and installers, there are currently no requirements in the ICC or NFPA codes for Firestop system installers to be certified or qualified by either manufacturers or third-party agencies, such as UL or FM. While such training and qualification is clearly a best practice, it is not mandatory. Let's discuss marking and identification. While not part of the Firestop inspection process, the proper identification of a rated assembly is critical. The IBC in 703.7, Marking and Identification, gives some very clear criteria for how these walls should be marked. In our example, we have a 1-hour fire and smoke barrier. This is good. I typically see 1-hour fire wall when we well know 1-hour fire walls don't exist. So let's correctly identify our walls. If they're a fire wall, fire barrier, fire partition, smoke barrier, or smoke partition. Let's correctly identify it. I think we can all agree on this. One last point I want to make. Individual penetrations for Firestop are not required by the code to be identified. This is typically found in the project specifications. While the International Building Code has very specific language for identifying and marking fire walls, fire barriers, smoke barriers, etc., there is no such language in the IBC concerning identification of Firestop. Identification stickers, such as the one you see on this slide, are typically provided by the manufacturer and are often required in the project specifications. Firestop materials can come in many different colors. Here are a few important rules to follow when it comes to the materials used in Firestop. Do not mix manufacturers' products in the same penetration. Mixing different brands of materials in the same penetration will void the fire rating of the UL or ASTM approved system. Whatever fire stopping method you employ, check to make sure that all materials and assemblies are approved by a nationally recognized testing facility for the specific type of Firestop to be installed. Never substitute approved materials with items such as mortar and concrete, expandable combustible foam, or other materials that cannot meet the required fire-resistant rating. Codes mandate through penetrations and joints must not be concealed from view until inspected A. by the architect, B. and approved, C. under the guidance of a general contractor, D. by the manufacturer. It is our desire that if we complete this program, that you have a better understanding of the process of Firestop, the relationship of the Chapter 17 special inspections, and the UL system approach to Firestop inspections, with basic Firestop fundamentals and the Firestop inspection processes of the ASTM standards. So this is going to conclude this section of the training on Firestop. Remember, there were 5 different sessions. I ask that you go through each one. Also, be sure to like and subscribe to this YouTube video. We appreciate that. It helps us along the way. And if there's any questions you got, email me. My email's showing up here on the screen for you. Reach out to us anytime, dolesmichael@gmail.com. We're in South Carolina. If we're in an area that we could come and visit with you or your group, we'll be glad to do that. So just sit back and go through all the videos. Try to glean as much information as you can. And again, this is, pretty much just my experience and my opinions on some things. We'll give you some really good references. And I wish you the very best with everything you're doing.